Right. So we are still continuing our discussion on quantitative aspects of chemical change. This is a topic that you need to be familiar with if you're doing physical sciences at grade 10 level. And in this video, we are mainly going to focus on concentration. We're going to define what is concentration, and you'll see how to go about solving problems involving concentration. So let us begin. So what do we mean when we talk about concentration? So I want you to imagine that you had a substance which we will call the solute. Um, this can be something like maybe salt, your normal household salt. And the solute, it's something that you will dissolve in a solvent. The most commonly used solvent will be like water or sometimes alcohol. There are many types of solvents. So if you take the solute or that substance, you add it into the water and then you stir, meaning now you are dissolving your salt into the water. What you will get, you will say that is a solution. So if this was salt and this is water, you will get something we call it a saline solution or sodium chloride solution. And when you have that solution, you can actually quantitatively or calculate its concentration. And hence, concentration is the amount of substance that is dissolved in a given volume of liquid. So if you have a liquid, it has a volume, and then your solute, you will have a certain mass, and you will see when we do calculations how does this work. So understand the definition of concentration. It is the amount of substance or solute that is dissolved in a certain volume of liquid. Right. So we can express what we've just described mathematically, where we say the concentration, which is represented by the letter C, is defined as the number of moles of solute, and this is the number of moles of the solute. It is remember, the solute is whatever substance we are dissolving into the liquid, right? Per meaning divided by volume of the solution, right? And then this is why we have this triangle over there that you need to familiarize yourself with. So you can look, you say C, which is my concentration, and we measure it in mole per cubic 3, that power of 3 is cubic per decimeters. So the concentration is given by the number of moles divided by the volume. So this means that you already spoken about moles, and you know this is how you measure it in mole. The volume, however, you need to determine or calculate it using cubic decimeters, right? And we can define 3 equations using this triangle over there. We've already defined the concentration, which will be N over V, or the number of moles per volume. And this is the number of moles of the solute. But the volume is for the whole solution when you have combined your solute or you have dissolved your solute in your solvent. And we can also say, okay, alternatively, you can find the number of moles, which will be given by the concentration multiplied by the volume. Or we can find the volume, which is given by the number of moles divided by the concentration, right? So like I mentioned, when you your volume, when you in your concentration calculation, your volume must be reported in cubic decimeters, and 1 liter equals to 1 cubic decimeters. But in questions, you're not always going to be given your volume in cubic decimeters. At other times, they'll give you in cubic centimeters or cubic meters. So you need to be able to convert back to cubic decimeters. So let's again, you need to understand that 1 liter equals to 1 cubic decimeter, and we are told that 1 milliliter is equals to cubic centimeters, or 1 cubic centimeters. And on the other side, we know that 1 kiloliter equals to cubic meter. But now how do you convert? So if you are given your volume in cubic centimeters, if you want to make it, to convert it into cubic decimeters, you will divide by 1,000. The opposite is true. If you would maybe want to convert your volume from cubic decimeters to cubic centimeters, you will just multiply. So don't get confused if they give you your volume in liters. You should know that 1 liter equals to 1 cubic decimeters, and if they give it to you in milliliters, you will know that 1 milliliter equals to cubic centimeters, and to convert to cubic decimeters, you simply divide by 1,000. The same is true here. If they've given you your volume in kiloliters or in cubic meters, and you want to convert it to cubic decimeters, you just need to multiply by 1,000. So spend some time looking at this image so that you know how to convert back and forth between the different measuring units, right? Or units of measure. So let us do a couple of calculations. So for us to learn how to calculate concentration, I would like for us to look at a number of questions. It's 4 questions in total. So the first question, they are saying to us, if 3.5 grams of the substance called sodium hydroxide is dissolved in 2.5 cubic decimeter of water, what is the concentration of the solution? And you must report your answer in mole per cubic decimeters, right? So let us try to solve that problem. So with physics or chemistry, physical sciences, it's always best to write what is given to you. What is it that you know? The first thing that you know is that you are given the mass, small letter m, the mass of a substance that they say it is sodium hydroxide. So it's NaOH. So it's NaOH. And that mass that is given to us is 3.5 grams. 3.5 grams, right? What else is given to you? You are actually given the volume of the water, which will also be the volume of the solution. So you can say V equals to 2.5, and they've given your volume in cubic decimeters, so you don't need to convert. So it's cubic decimeters. If they had given your mass in kilograms, you would actually need to convert to grams, right? But here they've just given it in grams, and they're asking us to calculate the concentration. So this is very straightforward. I'm just gonna say I know the formula for concentration is C, which is equals to the number of moles N of my solute. In this case, sodium hydroxide is your solute and water is your solvent, divided by volume. But you realize that I'm actually not given the number of moles. What is given to me is the mass, right? So how do I find the number of moles if I have the mass of a substance? If you've watched the previous 2 videos on quantitative aspects of chemical change, you will know that we said to calculate the number of moles, you simply say N equals to the mass of whatever substance, small letter m, divided by the molar mass of that substance, right? So we know the mass. It means that our task now is to find the molar mass of sodium hydroxide. And if you don't know how to find the molar mass of a compound, please refer to the first video that I did on quantitative aspects of chemical change. I've shown how to actually determine molar masses of compounds. So you say the molar mass of sodium hydroxide don't know what this ad is doing there on the screen. So the molar mass of sodium hydroxide, I found it to be 40.01. And how do you get to this value? You'll simply look in your periodic table. You'll find the molar mass of sodium, which is just equals to the relative atomic mass. And then you look at the molar mass of oxygen, the molar mass of hydrogen, and you add all of them together. So you say, okay, I now know the molar mass of sodium hydroxide. I also know the mass of sodium hydroxide. It means that I can find the number of moles. So you say the mass equals to 3.5 divided by 40.01. And that, when you calculate that, it will actually give us the number of moles. So it's just a matter of putting this in your calculator. When you say, okay, it's going to be 3.5 divided by 40.01. Then you convert it to a decimal. So you can write it to maybe 4 decimal places. It's going to be 0.87875, right? 0.0875, 0.08. Let me just write this down there because I see it's not going to fit. So you can say the number of moles equals to 0.0875 mole. But we are not done. What we need to do is actually calculate the concentration. So now you have the number of moles, you also have the volume. It means that you can now calculate the concentration. And remember, the concentration is given by this formula over there. So you see the number of moles, it's going to be 0.0875. It's 875, and the whole thing must be divided by the volume. We said the volume is 2.5. 2.5. If you put this in your calculator, you will find the concentration, the value for your concentration, right? So you just say, okay, it's going to be 0.0875, all of it divided by 2.5. How much is that? That is going to be 0.035. So it's going to be 0.035. Remember, concentration is measured in mole per cubic decimeters. D there means deci, and M means meter, and the power of is cubic, right? Let us go to the second question. So in the second question, we are required, let me see, So they say you have your volume, you have a 1 cubic decimeter container in which to prepare a solution of a substance called potassium permanganate. Now they're asking you what mass of potassium permanganate is needed to make a solution with a concentration of 0.2 mole cubic decimeters. So again, we need to find the mass. Let me do this. So we need to find the mass, which is small letter m. So you have m of that potassium permanganate, which we need to find, so we don't know it. So you need also to note down what is it that we do. I know C, I'm given C, the concentration of the solution, and they gave it to us as, so your concentration is 0.2 mole. Remember, your concentration, even when you calculate it, you must make sure that it's calculated in mole per cubic decimeters. Oh. So it's D cubic decimeters, right? What else is given to us? We are given the volume, right? So if you say the volume, they said it's 1 cubic decimeter. So you don't need to do any conversions here because everything is as it should be. So decimeters, right? And you need to find the mass. So if you remember, we have two equations that we will be using. We have the equation for concentration, which is the number of moles per volume. We also have another formula for the number of moles, which is the amount or the mass of whatever substance divided by the molar mass of that substance. So this is what we need to calculate for potassium permanganate. We can also determine this using our periodic table, the molar mass, right? And we will need to know the number of moles if you can determine this using the periodic table. So how do we find the number of moles? To find the number of moles, you can use this equation because I have the concentration, I have the volume, I just need to find the number of moles, and once I'm done finding the number of moles, I'll put it there and I'll be able to find the mass, right? So it's just a matter of rewriting this equation. You can say this is over 1, so it's a matter of course multiplying. So we'll say 1 multiplied by n equals to n. So any number multiplied by 1 is that number again, and then c multiplied by v, so you have c multiplied by v, and then you get cv. So what is my concentration? It's 0.2. You write it down. 0.2. What is my volume? My volume is just 1. So 0.2 multiplied by 1, it is 0.2, meaning the number of moles of potassium permanganate is 0.2. You must write that is in mole. So once you're done doing that, I can now come to this equation over there of the number of moles. So if I want to find the mass, I still need to also, let me just do this. So if I want to find the mass, I'm going to also do the cross multiplication thing because I want to make m, small letter m, the subject of my formula. So you're going to say 1 multiplied by m is going to be m, which is going to be equals to n, the number of moles multiplied by m. So you have n multiplied by m. I have the number of moles, I've just calculated it. Now I need to find the molar mass. And again, If you don't know how to calculate the molar mass of a compound, please refer to previous videos on quantitative aspects of chemical change. So now that's not potassium permanganate. So potassium permanganate is going to be K, which is potassium, Mn, which is manganese, O4. And when I did the calculation, make sure you also get the same value. The molar mass of potassium permanganate is going to be around 158 grams per mole. So there you are. So meaning that I can just say, okay, my mass, I just erase this and draw a better line. So my mass is going to be the number of moles, which is 0.2 multiplied by the molar mass, which is given as 158. 158. So 158. If you put that in your calculator, you will get a value. Let's see if you see clear this. So you say 0.2 multiplied by 158. So that is 31.6. 31.6 grams of potassium permanganate. So what does that mean? This means that to get a concentration of 0.2 mole per cubic decimeters, I will need to dissolve that 1.6 into this volume. So that is what it means. Let's move on to another question. So this question says, how much sodium chloride in grams? They are also asking us to calculate the mass. Will one need to prepare 500 cubic centimeters of solution with a concentration of 0.01 mole per cubic decimeters? It's more or less the same question as the one we just did. The only difference is the volume. You need to first convert. So you'll say, okay, what do I know? I know the volume, which is given as 500 cubic centimeters, but this is when you perform those concentration calculations, you need to have your volume in cubic decimeters. So to convert, as I mentioned earlier, to convert from cubic centimeters to cubic decimeters, I need to divide by 1,000. So meaning I'll actually have 500 divided by 1,000. So you can just say divided by 1,000. And that will actually give me 0.5 cubic decimeters. Cubic decimeters, right? So there we are. So what else do I know? They've also given me the concentration, and the concentration, they said it's 0.01 mole per cubic decimeters. So it's mole per cubic decimeters. Almost wrote a C there, so it's dm, cubic decimeters. So if I have the concentration and I have the volume, I can calculate the number of moles, and I've shown you how to rearrange this equation in the previous question, which says C equals to N, the number of moles per volume, meaning to get to the number of moles, it will just be N equals to CV. I've shown in the last question how to rearrange. So it's going to be C multiplied by V. So what is my C? My C is my concentration, which is C, is given by 0.01. What is my volume? My volume in cubic decimeters is given by 0.5. And you just need to put this again in your calculator and see what value is it that you get. And that will actually be your number of moles. So whatever answer you get, you'll report it in moles. Right? So let's do that. So 0.01 multiplied by 0.5. You see how much is that? And you find that it is 5 multiplied by 10 to the power of minus g, or you can write it as 0.005, right? Just that the answer there in your calculator is written in scientific notation, right? But it doesn't matter because we are not actually that much interested in the number of moles. That's not what we're calculating. What we're calculating is actually the mass, and that is the mass of sodium chloride. Remember, sodium chloride is salt. So we'll say to find the mass, I will need to look at this equation again, which says the number of moles equals to small letter m divided by big letter M, which is the molar mass. To find the small letter m, I've shown you in the last question, you need to rearrange that equation and you'll find that small letter m equals to the number of moles N multiplied by big letter M. And then you need to find the molar mass of sodium chloride. In the first video I did on the series on quantitative aspects of chemical change, I've shown you how to calculate the molar mass of a compound. So if you don't know how to do this, please go firstly watch that video. It will explain quite clearly how to determine molar mass, and the molar mass of this is going to be a value around 58.45. That's 58.45 grams per mole. Right? So now I have the number of moles and I also have big letter M. It means I can actually determine the mass. So small letter m, you can say, okay, the number of moles was 0.005 multiply by this value there of the molar mass, which is 58.45. 58.45. Then you'll say, okay, put that in my calculator and see how much you get. So 0.005 multiplied by 58.45. Then you say, okay, how much is that? And you're gonna get a value of about 0.29 something. So you can round off your answer to 2 decimal places. So you say your mass equals to 0.29 grams. So you've answered your questions. So you will say, in order to prepare a solution with a volume of 500 cubic centimeters, and for that solution to have this concentration, I will need to add how much we find 0.29 grams of sodium chloride. Now for the last question. In the last question, they are saying how many moles of this is sulfuric acid H2SO4 are there in 250 cubic centimeters of 0.8 mole per cubic decimeter sulfuric acid solution. And also the second question is what mass of acid is in this solution. The same thing if you look at it again that we have just did. The only difference is the volume. So we say, okay, what do I know about that solution? I know that the its concentration is 0.8, so 0.8 mole, so 0.8 mole per cubic decimeters. So per cubic decimeters, we write dm to the power of 3. Right? What else do I know? I know the volume, and that volume is given as 250. But I know because the volume is given in cubic centimeters, I will need to first divide it by 1000 in order to have it in cubic decimeters, because that's what we need to calculate the concentration. So 250 divided by 1000, you can just say, okay, 250 is going to give us 0.25 divided by 1000. So how much is that? So you see that it gives us 0.25. So it's okay. My volume is 0.25 cubic decimeters. So you say, okay, cubic decimeters. Fine. What else do I know? If I have this, if I also have this, I can calculate the number of moles by using that equation, and the number of moles after rearranging this equation here is just going to be N equals to CV. C multiplied by V. So what is my C? My C is 0.8. So 0.8, 0.8 multiplied by 0.25. And I think you're going to get something like 0.2. But let's check on the calculator. So you have 0.8 multiplied by 0.25, right? And how much is that? It's going to be 0.2. So meaning that there's 0.2 moles of sulfuric acid in that solution. So we've answered the first question in terms of the number of moles of sulfuric acid in the entire solution. Now we need to find the mass of sulfuric acid that was dissolved in whatever respective volume. Again, you'll say I have the number of moles. I just need to find the molar mass of H2SO4, which is sulfuric acid. And again, if you don't know how to do that, please watch the first video I did on quantitative aspects of chemical change. It explains in detail how to find the molar mass of compounds. So we say it's 98.02 grams per mole. Depending on the periodic table that you're using, the value you get will be more or just a little more, just a little less to this value, right? So if I have the molar mass and I have the number of moles, I can actually, in essence, calculate the mass. So I can say, okay, M equals to the number of moles multiplied by the molar mass. So you say, what is my number of moles? We found the number of moles where it's 0.2. So 0.2 multiplied by the molar mass, which is 98.02. And you get a certain value. Put that on your calculator. Let's see. So if there is 0.2 multiplied by 98.02, how much is that? And it says it's 19,604 grams. So what does this mean? You need to dissolve 19.06,604 into a certain volume of the solvent, which is that volume was given to us as 250 cubic centimeters. So this is the mesh that you actually need. These types of calculations are very straightforward, and you will need to know how to calculate them. So when you are given the concentration or the volume, be able to calculate the number of moles, and also from the number of moles and molar mass, be able to calculate the mass. And then in the next video, I will do the last video on the series on quantitative aspects of chemical change, and in that video we actually going to talk about volumes of gases at STP, or standard temperature and pressure. So hopefully you were able to understand this section on quantitative aspects of chemical change.